Hi everyone, so these are the solutions to the multipliers exercise. I've got the solutions project to the deer pellet exercise open in distance, and the first thing I wanted to show you is if we look at the instructions from the project, you were asked to first of all adjust the multipliers to match the information that you were given in the instructions. So when we look at how the data have been entered into this project, you can see that we've got the defecation rate, which was the 25 pellets that was noted in the instructions. It didn't have a measure of variance, though, with that estimate. But for the decay rate, we did have both the decay rate and the standard error, so these have been placed into distance. You'll also notice that we've got information for 8 out of the 9 blocks, so there was clearly one block that had no effort placed in it. So if we go to the solutions, you can see that we have given you solutions where we've fitted just a few different detection functions, but we've not gone through the whole we haven't gone through a full detection function fitting exercise, so you may have found a detection function that you think was a better fit to the solutions we're presenting here. However, what we've done is we truncated at 10%, so we got rid of the 10% of the most distant pellet groups. And so I'll show you the results and the analysis set up for the stratified analysis we asked you to do in the instructions. So first of all, let's take a look at the way that we've set this up. So you can see up in the data filter we've taken those 10% for our truncation, which I can show you here. So we've discarded the largest 10% of all distances. And if I take a look at the model definition we've used, starting with the detection function, we've allowed a half normal with cosine adjustments. We've left it on the default with an automated selection. If I go back to the estimates in the model definition properties, you can see that we've asked for density both at the global level and the per stratum level as requested in the instructions. The encounter rate has been estimated on a per stratum basis only. We've used a global detection function in this case. And then notice that the global density estimate we've asked for is the mean of the stratum estimates weighted by the total effort in each of the strata. So let's move on to looking at some of the results. So the first thing to note is we had a few warning messages in the analysis. So looking at the log tab, we can see what they are. We've got some encounter rate variance warning messages for stratum 5, 7 and 8, and we'll come on to that in the results later on. Notice though it says it couldn't be estimated as there was only one sample in each of those strata. And then a warning that you often see is that for our QQ plot, the number of points displayed is only 500 out of a possible 1700 that we have in this data set. So let's take a look at some of the results. So if we take a look at the model fitting first of all with this half normal, you can see that it first tried just a half normal on its own. It then tried one cosine adjustment, followed by a third model with 2 cosine adjustments, but based on AIC, it selected model 2, so that's the detection function we're working with in this case. If we skip through the results to have a look at the global detection function, remember that it will be fitted, it will be displayed with different binning for the histogram. So in order to, if you flick through the results, you should find the plot that matches the one in the solutions. And you were asked to look at the encounter rates per block. So again, we can skip through the solutions to the summary, and you can see all of the encounter rates for each of the blocks. Now notice for those 3 blocks that generated warnings, when you look at the K for the number of samples in each block, which is the number of lines, if you go down to the ones that generated the warning, so for example block F, you can see that there was only 1 line within that block, which resulted in the analysis being unable to estimate an encounter rate variance, so you have 0 for those blocks. You were then asked to find the overall density estimate based on the mean of the woodland specific density estimates weighted by the total effort in each of the blocks. And so if we look at our summary information about the per block density estimates, you can see that in block A there was a very high density estimate of 73, and then the rest are somewhat lower. So if we move to looking at our overall density estimate, the mean density estimate is 36, which is somewhere in between all of the per block density estimates, as you'd expect. So the next thing we wanted you to have a look at was to look at the components of variance. And when we take a look at any of the blocks, you'll notice you get this very useful summary table. And you can see now that decay rate is added to the summary table because it was a parameter which had an associated variance, and so it's been included in this calculation. And so just by flicking through these results, you can just get a feel for the differences between these blocks and how the different parameters contribute to the overall variance in each of the blocks. So for example, in Woodland A, there were 13 transects and 1200 pellet groups. And we can see here number of samples in block A, here's the number of observations. And the overall density estimate variance was a CV of 19%. And when you look at the component percentages of the variance, you can see that detection probability contributes very little. The encounter rate is nearly 80% of that variance, and the decay rate is about 17% of the variance. Now remember, we had a dung production rate, which was also estimated, but we didn't have an associated measure of uncertainty with that. So ideally, we'd also have the dung production rate also contributing to this table. But we don't, not because it doesn't have uncertainty, just because we didn't have that information for this analysis. If we contrast block A with another of the blocks, so let's take a look at block E, we can see that there were fewer samples here, so only 5 lines completed, and fewer observations, just 30 observations. So now we can see that the detection probability has a much lower contribution to the overall variance for this block, and that encounter rate is forming nearly 97% of the uncertainty associated with the density estimate in this block. And again, decay rate has a greater contribution than detection probability, as with block A, but also is very small compared to the encounter rate variance. Now let's finally look at block F, which was one of the ones where, as we see here, had only one transect completed, similar number of observations to block E, but when we look at what distance can do with the data it has, you'll notice that the encounter rate variance is unable to be estimated and therefore has not been included in the component percentages of the density estimate variance. And so the solutions basically ask you to really think about, do you trust the uncertainty in this block F? We only have a single transect, and so we're assuming there's no encounter rate variance in this block. But if you compare to some of the previous blocks, which had a very high encounter rate uncertainty associated with those blocks, do we believe that block F happens to have no encounter rate uncertainty, or is it that we just have one transect line and so we can't ask the question of block F? And then finally, the last point in the solutions is, again, I've mentioned it before, but we had no variability in the dung production rates. And so again, that's not included in the analysis here, but should ideally be a part of the analysis because it is a parameter for which we are not 100% certain about. So that works us through the main results, and I think that's all there is to say about this particular exercise.